objective here is to give you a broad overview on, what's the implication of AI on the IAM domain. Following my session, there will be a deep dive into agent identity, so I hope you'll be looking forward to that as well. So there are three kinds of relationships between AI and IAM. So I call this the IAM AI triad. So the first relationship is IAM for AI. So IAM for AI is about how you enable secure development of agents in your organization. Then we have AI for IAM. So AI for IAM is how you can use AI in your organization to make your IAM development and administration more efficient, as well as how you can leverage IAM to improve your cybersecurity. And then we have IAM versus AI. That is basically how you can use IAM to counter the threats that are posed by AI-based attacks. So my talk is going to be structured based on these three topics, so that will make it easier for you to follow. So first, let's start with IAM for AI. So very soon, your next multi-million-dollar customer could be an AI agent, right? So why do I say so? Because we are already seeing AI agents replacing human employees in organization. That's already becoming a reality. And these agents, for example, like a procurement agent, can be managing orders, managing deliveries, managing payments, managing suppliers, right? And then from the supplier perspective, from the external perspective, these suppliers are interacting with your procurement agent, right? So for those suppliers, this AI agent is a customer, right? So you can see how the AI agent is behaving as an employee, and then he's also behaving as a customer for external parties. So it's a very interesting time that we have. Now, this kind of dynamic creates new opportunities as well as a lot of new challenges. So some of the recent surveys have shown that by 2028, there is going to be 15% of day-to-day decisions are going to be taken by AI agents, right? And by 2028, 33% of the enterprise applications are going to include agentic capabilities, right? There's a lot of hype about AIs. Somewhere else I read that almost 90% of organizations are embracing AI in some form or the other, but only about 44% of organizations have kind of governance for AI. So it's a kind of a dangerous situation, right? But that doesn't mean we can put the brakes on adopting AI. We'll have to somehow find suitable ways of embracing AI and using it safely in our organizations. So in the next couple of years, the biggest challenge that IAM is going to face is the identity sprawl, right? So earlier days, we had few identities, like hundreds of identities and thousands of authorization requests. Then with the advent of cloud, SaaS applications, devices, IoT devices, etc., we now have like thousands of identities and billions of authorization requests. But what we are going to see in the future is we are going to have billions of identities and trillions of authorization requests. So that's the exponential growth of identities we are having to deal with. That is because every employee in your organization is going to create an army of AI agents, and those AI agents in turn are going to create other agents, and that's going to create this identity sprawl. So now where does agent ID fit into the existing identity landscape? So this kind of shows you the categorization of the different identity types. So first we need to realize that, or we need to accept that agent ID needs to be treated as a first-class identity, and there is good reason for that. So agents have this duality within them. Agents sometimes behave like humans. They inherit human capabilities. They can sense, they can reason out, and they can act, and they can make decisions. But also sometimes they behave like machines, as in machine speed, right? So they need the identity of their own, right? As well as they are slightly specialized than normal workloads, because they can, if needed, in order to make decisions, they can request for additional permissions as well, which is not the case with workloads, right? They have fixed permissions. So therefore, we need to treat agent IDs specially. And although traditional IAM hasn't fully figured out how to manage agent identities, most organizations have started clubbing agent identities along with machine IDs. And there are good reasons, because both of them are coming from the non-human identity side of things, as well as both of them inherit the same problems. Agent IDs inherit the same problems as machine IDs. For example, there is a lack of visibility of all the non-human identities in organizations. There is a lack of governance of these identities, because these identities are not typically managed through IGA life cycles. Different teams create these identities in ad hoc ways, so there is no single source of truth. Most of these non-human identities don't have proper secure authentication mechanisms like MFA. So there are a lot of common challenges between these non-human identities. So it's a good place to start by modeling agent IDs as machine IDs. As well as modeling agent IDs, agents as identities, aligns well with the identity-first security principle as well. Because what identity-first security principle says is that any entity that is accessing a resource, if it needs to be managed, that needs to be modeled in your control plane of the cybersecurity architecture, which is the IAM, right? And all the policies, access control policies, governance policies, everything needs to be enforced centrally, applied centrally, and then enforced in a decentralized manner. So it's a good place to start. So then if we look at the governance framework for AI agents, there are 4 key steps when it comes to AI agents. So I'm not going to go into the implementation details, but at a very high level, these are the 4 key steps. First of all, you need to have visibility. So you need to take stock of all the agent identities that are there in your environments across the cloud, on-prem. You need to categorize them by the type, by the purpose. You can categorize them by the state in the life cycle they are in. So you need to know all the agent identities that are there. And then you need to have also visibility into the accesses they have. So what are they accessing, what are the resources, on whose behalf they are accessing, and why are they accessing, so on and so forth. So that's the visibility part. Then you need to have ownership. So every agent needs to have an owner, right? And if agents are creating other agents, then you need to have a chain of custody as well. And you need to also understand what is the intention of this agent, and what are the required access for these agents, so on and so forth, right? And then you come to the compliance part. So this is where you basically evaluate whether the agent is accessing, if an agent is accessing a particular resource, whether that access is required in order to accomplish his goal, right? So that's basically what you look under compliance. So how do you do that? You do that by implementing controls like role-based access control, attribute-based access control, and policy-based access control. You also need to do things like access reviews for agents, right? Also, you need to, you can do risk-based assessments. You look at the past behaviors of agents and the current behaviors of the agent. You look at what is the permission levels of the owner of that agent and what does the agent have. So these are things you can do in order to make sure your agents are compliant. And usually this compliance is implemented using AI gateways or like a plug-in to the AI platforms. And finally, you have accountability. So every action that an agent does has to be audited, and those fine-grained audits have to go into like a SIEM solution or whatever solution. And if and you'll be immediately, you can immediately detect that if an agent has gone rogue, what has happened and what's the impact, and you can take steps to mitigate some of that impact. As well as if there are agents who don't have owners, who are orphan agents, you can plan who is going to be the next owner. So another thing is we talked about the identity sprawl. So in large organizations, these identities can go into like the thousands, right? So it's going to be very hard to manage. So in a large organization where there are like divisions or teams who are managing, who are creating their own agents, it will be helpful if we can delegate that administration and management to the teams themselves so that they can apply their own governance and manage their own agents. So that's where IAM solution that has the capability of managing organizations or sub-organizations will help, right? So you can delegate the administration of these agents to the organizations themselves, as well as you can also have capabilities where you can define an agent at a particular level and then share that agent with sub-organizations as well if that's the requirement, right? So this allows you to have centralized governance at the very top, but decentralized enablement at the bottom. So I'll not go into a lot of detail on the protocols, but these are some of the protocols that we are dealing with today in the agent identity world. Of course, we have the on behalf of flow, which inherits from OAuth, which allows agents to obtain restricted permissions from users for a limited time to access resources on behalf of users. And then we have MCP for calling tools. Then we have A2A, which is kind of in infancy, so you should be cautious of using some of these standards for agent-to-agent collaboration. We have dynamic client registration. If agents want to create other agents, then you need to use this. Then for fine-grained authorizations for agents, we have attribute-based access control, relationship-based access control, and RA. Then for human-in-the-loop approvals, we have CIBA, client-initiated back-channel authentication. Then for cross-domain agent collaboration, we have workload federation and token exchanges, as well as for credential management of agents, we have Secure Vault, right? And the latest implementations also support things like, entering the agent credentials in an agentic browser without the agent getting access to these credentials or the LLM getting access to these credentials. So these are the things we are kind of looking at the moment. And there are some emerging protocols also that are coming up. So you can just be aware of what's happening in this space. All right, so that's basically IAM for AI, and we'll have a deeper dive on that topic in the next session. So next we'll look at AI versus IAM. So AI is actually enabling direct attacks on the foundation of IAM, right? So you can see the attacks, AI-based attacks such as deepfakes and attacks powered by AI tools are on the rise, right? So this is very concerning, right? So when we look at deepfake attacks, there are broadly two types. We have deepfake attacks on the biometric processes, as well as we have deepfake-based social engineering attacks. So when we talk about biometric processes, it can be attacks on the voice, attacks based on the facial biometrics, and on the social engineering side, attacks could be based on an audio call or a video call. So if we look at deepfake voices, it's quite easy for attackers to create deepfake voices, right? There are a lot of online services that provide free capability to create deepfake voices, and with a sample of less than a minute, you can create deepfake voices. But obviously, if you are able to pay more, and if you can create a bigger sample, then you can produce high-quality voices, right? So how do we? What are the capabilities that are there to mitigate these deepfake voice threats, right? So there are multiple capabilities based on AI, right? So these, I'm not going to go into the detail, but there are capabilities such as analyzing the perceptual features of the voice, such as the pitch deviation and the cadence of the voice. Then there are technical capabilities such as spectral feature-based detection, looking at the spectral centroid, spectral contrast, spectral flux, etc. Then you can train deep neural networks using a large amount of synthetic and real voices. And then there are newer models such as machine vision, where you can translate the voice samples into images, and then using voice-based machine learning or deep neural networks you can analyze for deepfake voices. So these are some techniques that are used commonly to detect deepfake voices. One of the things is that these techniques are very accurate when you try them out on deepfake voices that are created by the same tools that are used to train these models. But then when there are voices created using other tools, the accuracy really drops, right? So that's something to keep in mind. Most customers are actually using these kind of techniques, integrating with vendors who are providing these solutions based on the ease of integration. And it's always better to use multi-layered defense, not just use voice detection, but also on top of that use other signals like call ID spoofing, IMEI spoofing, SIM swap, etc., to arrive at a more accurate decision on whether the voice is deepfake or not. So these are some other signals you can consider in your analysis. Then we have face deepfakes, right? So the face deepfakes are mostly used in online identity verification, right? So there are two types of deepfakes when it comes to face. One is presentation attacks. The other one is injection attacks, right? So presentation attacks is basically you have created a fraudulent artifact of the face and then you are presenting that to the camera or the sensor, right? Whereas injection attacks is basically you have somehow bypassed the physical camera and you have given the face, the image to the IDV process, right? So these are the two types. So for example, how you can do presentation attacks, so there are simple ways, like you can take a picture of the person and then you can show it to the camera, or you can go to their Instagram profile or Facebook profile and you can project that picture on a large HD monitor and then show that to the camera, right? Or you can even use sophisticated things like masks and then take a selfie and show it to the camera. Also, you can, but those are not really deep fakes, but if you want to do a real deep fake thing, you can create a deep fake image, project it on a monitor, and then show it to the camera, right? So those are deep fake, presentation-based deep fake attacks, right? On the injection side, how it's typically done is they use virtual cameras or mobile phone emulators, etc., right? So that's how injection attacks happen. So to prevent these deepfake face attacks, there are some techniques that are used. One is image processing techniques such as recognizing facial landmark alignment and mobility. They look at the blinking. They can look at some details features such as the shadows, the repeated backgrounds, etc. So those are some techniques based on image processing. Then they can look at neural network techniques. So they can use convolutional neural networks to detect pixel level anomalies, or RNNs to detect temporal inconsistencies between frames. And then we have GAN or diffusion fingerprint detection. So usually when you create deep fakes, you use this technique called GAN or diffusion. And usually when you do that, there is some sort of fingerprint that is left in the image, which kind of tells you that this is a deep fake. So it's not usually visible to the naked eye, but when you do analyze the image, you can find these fingerprints. So that is one way to detect that this is a deep fake image. And so there are some standards also that are coming up for this. So there is already an ISO standard for presentation attacks. So many vendors are starting to support this. And then there is a European committee standard which is coming up for injection attacks as well. So just be aware of that when you're looking into evaluating these vendors. So like voice, even for face deep fakes, you need to use a multi-layered defense approach. So there are other signals that you can use in order to detect deepfake attacks, right? For example, you can use like device and behavioral intelligence. For example, if the same device is being, you're seeing the same device being repeated in multiple IDV processes, then it might be like an attack. Or if you're seeing that the user is behaving in an abnormal way, then it can be a deepfake attack. Or then there are features that you can see from liveness detection, where you can see the light that is reflecting from the face and various other features to test liveness. Then, for example, you can check for screen detection techniques to see whether the image is being projected from a screen. For example, then there is metadata inspection. So when an image is sent from the camera, from metadata, you might be able to figure out that this image is being presented by a, say, an iPhone 12, right? But you know that the iPhone 12 creates an image that is like of resolution, say, 4,000 into 5,000, right? But the image that is coming is of resolution like, say, 1,000 into 2,000. So based on that, you can detect that this is a deepfake attack, right? And you can take measures. And then watermarks are also used. Like some vendors in their SDKs, they create these watermarks in the image. Like it will be like a very small black dot in the image that is again not visible to the eye. So when you analyze the image, if that watermark is not to be seen, then it could be possibly a deepfake, right? So those are some additional techniques that you need to use. And then finally, social engineering against employees. So this is another common kind of deepfake attack where AI bots join voice calls and video calls and then present as a legitimate user. So like 2 years back in 24, I think, there was an incident where in a UK-based engineering company, there was a remote worker from Hong Kong who was tricked into believing that he's speaking with his CFO, and they had transferred almost 20 million pounds of money. So that kind of attacks have happened, right? So to prevent this, there are solutions that are coming up. There are some startups that are coming up. Basically what they do is they join AI bot to the call, like the note-taking bots that we are familiar with. And this bot will listen to the audio and video streams, and it will send it to the backend servers, and they will do the analysis. And if it is found to be deep fakes, then they will alert the other participants in the call. So these are some techniques being used. Right, so that's about deep fakes. So then finally we come to AI for IAM. That is how to use AI to improve the efficiency and cybersecurity of IAM, right? So AI is making the IAM interactions more smarter and more conversational, which is interesting. But not all IAM use cases are a fit for AI, right? Typically, if a use case can be done by humans and the priority is acceleration, make it faster, then it's a perfect fit for AI, right? But if you need human accountability on the use case, as well as if priority is quality, then maybe it's a fit for use case. You need to evaluate case by case and see. But definitely, if real-time or near real-time responsiveness is needed or requires deterministic decisions, then it is not a fit for Gen AI, right? Because Gen AI is never real-time responsive and it is not deterministic, right? So, for example, authentication and authorization are two examples where Gen AI is not a fit at all, right? Because they require high performance and they must be they must have a deterministic decision. Sorry. All right, so then what are the suitable use cases for Gen AI, right? So there are a number of suitable use cases for Gen AI. So one is access modeling, right? So access modeling is previously called as role mining. So you can, what access modeling can do is Gen AI can look at all the identities in your environments, their attributes, their entitlements, roles, groups, etc. And it can detect patterns, right? It can detect patterns, and then it can recommend who are some of the users who may need additional roles in order to perform their duties, or who are some of the users who have more than required roles, which you need to remove from them, right? It can also suggest users, end users to request access for additional roles in order to perform their duties, right? So these are some of the things that Gen AI can do in access modeling. Then approval recommendations, right? So we all know, like, human approvals are just a rubber stamping process in many companies, right? People don't have the time to do that, right? So Gen AI can actually approve 90% of the requests in companies, and only about 5% of the requests need to be escalated to an actual human, right? So this gives a lot of productivity gain. Then we have integrations. So, IAM needs to integrate with other applications for provisioning, deprovisioning, entitlements, etc. And this is a lot of work, and especially it's a lot of services work, right? It takes months to create these connectors, right? But in future, we might not need these connectors at all, because Gen AI can help map that application schema to the IAM schema, and normalize that data and read that data into the IAM product, right? So you might not need connectors in future with Gen AI. Then there are other use cases like automation. So you can use Gen AI to automate the deployment, updates, and operations of the IAM system. Then you can use Gen AI to create, your reports. So you don't have to limit yourself with the vendor's reports. You can create your own reports. So these are some capabilities that you can use Gen AI for in IAM. And we all talk about Gen AI and agentic identity, which are the new kids on the block, the cool kids on the block. But machine learning also has good use in IAM still, right? So machine learning can be used for continuous risk-based authentication. So that will also come under AI for IAM, right? So you can use machine learning to detect, listen to these risk signals from users, devices, etc., and then generate a risk score, and based on that, provide dynamic access to users, right? So that's also another use case. So finally, we spoke about a lot of capabilities, right? You might be wondering whether all these capabilities can be expected to be there in a single IAM vendor. So the answer is no, right? So this is where we talk about the identity fabric, right? So the identity fabric is basically an architecture that enables identity-first security. So there are two ways of achieving the identity fabric architecture. A group of vendors would use a converged IAM approach, where they try to build out at least majority of these features by themselves, right? Nobody is 100% complete, at least the majority is there. Then there are another camp of vendors who would specialize on certain components, but enable integration with other components, right? So either way is fine. So at WSO2, we believe the specializing is better, because betting on one vendor for all your IAM needs or all your security needs is a risk, especially in this in the current geopolitical situation in the world. So therefore, you have to reduce your risk. So we believe in choosing best of breed solutions and composing this identity fabric architecture. Right, so basically that brings me to the end of my talk. So again, AI is not just another technology cycle, it is a paradigm shift that is underway, and IAM is not an exception. It is also being reconstructed like every other field. And it's not just the technology that you need to adapt. I think organizations will have to look at other changes as well. So they have to look at teams, organization structures, team structures. They need to look at new skills that need to be acquired. They need to create like cross-functional teams, and even look at different ways of incentivizing their employees, right? So there are a lot of changes we can expect. Some people are even predicting whether we can completely get rid of IAM and delegate everything to the agents. We can forget about IAM, but I think that's too far-fetched. At least today, I think for the foreseen future, IAM will still be a discipline that needs to be there. But of course, the practices that we follow around IAM is going to be transformed hugely. Right. So thank you very much. That's what I wanted to share. Thanks.